Hello and welcome to the Embedded Tech Podcast, the show that dives deep into the challenges and innovations shaping embedded systems design. I'm Dunstan Power, Director at ByteSnap Design and your host for today's episode. I'm delighted to welcome Paige West from Electronic Specifier to the show. Paige brings extensive experience covering the electronics industry and has keen insights into the challenges manufacturers face with rapidly evolving technology. Welcome, Paige. Thanks for joining us today. And for the benefit of our listeners, would you like to tell us a little bit more about your journey in electronics and your current role?
Yeah, sure. Thank you very much. So I have been in the industry for just over 10 years now. I graduated from the University of Greenwich in 2014 with an English literature degree. So I don't have an engineering background. I don't have an electronics background. This was a world that I never knew existed until I joined it. And it's fascinating. I love this industry. It was never my plan to write for an engineering or an electronics magazine, but as soon as I started, I fell in love with the topic, with the people. I think engineers are really fascinating to talk to, and it's always a pleasure to hear the latest innovations and to see the passion that these engineering teams have. So I joined Electronic Specifier about 3 years ago now as managing editor. And for those that don't know, Electronic Specifier is a leading B2B media platform that serves the global electronics industry. We're headquartered in the UK, just outside of London in the southeast. And we essentially provide engineers and designers with the latest news and technical insight and product information across various sectors. So we have a suite of digital publications, and I've got my own podcast, and we have print magazines, and we attend events and do webinars, and you name it, we do it. So, yep, that's me.
Yeah, great. Yeah, that's absolutely fascinating. Today, we're tackling a challenge that's becoming increasingly critical for manufacturers across the UK and beyond: technological obsolescence. If you've ever had a component suddenly become unavailable or found your production line threatened by end-of-life announcements, you'll know exactly how disruptive this can be. We recently completed a comprehensive research study on this very topic, surveying 593 industry professionals, including engineering managers, production managers, and design engineers from companies of various sizes. And what we found was a striking 88% of manufacturers encounter obsolescence issues at least annually, with 27% of these facing them quarterly. Even more concerning, 81% struggle to find reliable partners with the right expertise to help them address these issues. The U-Block's announcement withdrawing from the cellular module market is just one recent example that sent shockwaves through the manufacturing community, with some companies facing redesign costs exceeding £250,000 and delays extending into 2026. But it's not all doom and gloom. Our research also revealed that proactive management can reduce costs by up to 80% compared to crisis responses. Today, we'll be exploring practical strategies for managing obsolescence based on both our research findings and Paige's experience in the industry. So whether you're currently battling component shortages, planning for future-proofing your designs, or simply wanting to stay ahead of technological change, today's conversation should provide valuable insights for your business. Let's get started. Paige, as someone who covers the electronics industry extensively, were you surprised by our finding that 88% of manufacturers face obsolescence issues at least annually?
Not particularly. I mean, 88% is a striking figure, but it's not surprising given the pace of change in both the electronics and industrial technology. I think what stood out to me is how widespread and routine these obsolescence challenges have become. Manufacturers are relying more heavily on embedded and connected systems, yet many still lack formal life cycle strategies to support them. And the result is that obsolescence is no longer a future problem. It's a reoccurring operational risk. And I often hear from engineering teams that component availability is one of their biggest pain points, especially when dealing with legacy systems alongside new IoT deployments. And I think your report puts data behind what many in the industry have been experiencing.
Yeah, so what they know intuitively, yeah. And from your perspective, covering the industry, how has the obsolescence challenge evolved in recent years?
I think it's definitely intensified. In the past, it was often seen as a rather niche concern, sort of usually limited to specific industries like defence or medical, where long product life cycles made sourcing legacy components difficult. But today, it's become a much broader issue, largely due to the rise of these connected systems and the accelerating adoption of industrial IoT. And I've seen a growing dependency on complex multi-layered electronics that rely on a wide range of components, many of which have shorter commercial lifespans. And at the same time, we obviously have supply chain volatility, particularly post-pandemic, which has exposed just how vulnerable manufacturers can be when a critical part goes end of life unexpectedly.
Yeah, and the study showed that a 28%, so like a quarter of manufacturers actually hitting these problems quarterly. Does that sort of ring true to you from what you know?
Yeah, I think that definitely aligns with what I'm hearing from our readers. Across the board, engineers and even procurement professionals tell us that obsolescence is no longer a once in a blue moon disruption. For some, especially those managing legacy systems alongside these newer IoT deployments, it's become a near constant challenge, and the pace of component change, shorter product life cycles from suppliers, and constrained availability all contribute to this cycle of forced redesigns and last minute
Yeah,
substitutions.
yeah,
We regularly hear from readers in sectors like industrial automation, medical, transportation, where systems are expected to remain in the field for 10, 20, 30 years.
yeah.
And for them, even a minor component becoming unavailable can mean major delays, increased costs, or full system rethink. And, I think the 28% speaks to just how serious or embedded this problem has become.
Yeah, we do a lot of industrial design work, and certainly we've seen, um, we have customers where they want products that will last in field for 20 years. We had a seabed project, for instance, where they couldn't work on it, and but also they want to be able to provide spares, maintenance, board-in replacements that are identical over those sorts of periods. So yeah, this is a real problem. The U-block cellular withdrawal created significant disruption. I mean, it's some of our customers, for instance. I mean, what similar cases have you observed recently?
Yeah, great example. That definitely caused some very notable disruption. I think particularly because it impacted a wide range of industrial and IoT products that had been designed specifically around those modules. And it's a prime example of how dependent manufacturers have become on a small number of highly integrated components, and just how difficult it can be to pivot when those components are withdrawn unexpectedly. Um, Although it was recently announced that I think uBlocks have transferred their cellular IoT module business to Trasna, which are a semiconductor and IoT solutions provider. But another recent example is with NXP. They planned end of life for their Core LQ P series processors. They were used widely across networking, industrial, and defense applications.
Right.
But they received notice from their foundry that the P series could no longer be produced, and they issued a last time buy notification. And that withdrawal impacts long term product support, particularly for designs that rely on specific performance or power profiles and have extended deployment life cycles. So,
Yeah,
yeah.
it particularly affects industrial type designs where it's not a rapidly changing thing like a consumer goods where you've got a natural life cycle of only a few years anyway, so people can do last time buys and ride it out. I mean, one of the most striking findings we found was that 81% of manufacturers struggle to find design partners with the right expertise. Again, does that match what you're hearing from the industry?
Yeah, very much in line with what we've been hearing. with the rising complexity of embedded systems and the rapid pace of technological change, I think manufacturers often report difficulties sourcing partners who not only understand the hardware but can also deliver long-term lifecycle strategies. And this is especially true in highly regulated or industrial sectors where things like compliance and security and obsolescence planning are crucial. And I think the shortage of experienced engineers and specialists only amplifies this challenge, and it leaves many firms exposed when key components or technologies shift unexpectedly.
And what factors do you think contribute to this disconnect between the manufacturer's needs and the available expertise?
I think it's two things: the pace of technological change, which I've mentioned already, but electronics evolve rapidly, and many manufacturers struggle to keep up with this shifting landscape. You know, there's changing components, changing standards, changing lifestyle expectations, and also what I just said about the skills gap that we have. You know, as your report highlights, experienced engineers are retiring, and there's a shortage of
Yeah,
specialists with deep knowledge of embedded systems and life cycle planning, and we have yet to replace them.
yeah. I mean, some of the projects we've worked on are things like Windows CE, where the software was obsoleted decades ago, but it's still being used because of regulatory environment, and so but people with the skill set to deal with obsolescence issues around that are pretty thin on the ground because it's such an old system. Um, from your coverage of the industry, which sectors seem to be handling this expertise gap most effectively?
I think sectors with high regulatory pressure and long product life cycles, so medical, aerospace, transportation, they appear to be handling the gap the most effectively. I think they often have more mature risk management processes and greater investment in long
Yeah,
term
yeah,
support infrastructure anyway. So, you know, for example, medical manufacturers are heavily focused on compliance and documentation, so they're more likely to integrate life cycle planning from the start.
absolutely, yeah, yeah.
Aerospace and defence firms, they always work closely with authorised aftermarket suppliers anyway to secure long-term availability. And same with rail and industrial automation. They've always shown a strong adoption of obsolescence monitoring tools, I think due to the extended operational life of infrastructure equipment.
Yeah, that makes a lot of sense. I guess also there's a scale issue there as well, that those sorts of companies tend to be larger. Defense, healthcare, rail, naturally tend to be at the larger end of either large SMEs or corporates. So they're more likely to have sort of separate compliance departments and things. Whereas small, medium-sized companies don't necessarily have the skills in house around dealing with these things.
Very true.
So our research indicates that proactive obsolescence management can reduce costs by up to 80%. What cost factors do you see most impacted by obsolescence?
I think the biggest one is redesign costs. So when components become obsolete, manufacturers face expensive redesigns to find alternatives or re-engineer their systems, and this can be particularly costly in complex long life devices like industrial machinery or medical equipment. There's also supply chain disruptions. So when a component goes obsolete, sourcing alternatives can lead to delays, inventory shortages, and potential fines for missed deadlines as well, which leads me on to the next point, which is downtime and production delays. So obsolescence can also disrupt operations, causing production stoppages and time to market delays that essentially just further escalate costs.
And the white paper we authored on this identifies several hidden costs of obsolescence. What are the hidden costs that you think companies most frequently overlook?
I think things like it comes down to brand reputation damage, which doesn't
Yeah,
sound like it's going to be costly, but if a company has continuous disruptions, particularly in critical sectors like, again, healthcare, aerospace, it can really tarnish a manufacturer's reliability in the market, and it can also you know, affect a company's ability to meet evolving standards, which can also lead to potential legal and operational risks. So it's small things like that that have the long term costly impact, and also can lead to reduced competitiveness as well. Manufacturers may struggle to integrate newer technologies, which means they fall behind their competitors who've already invested in these future-proof systems.
Yeah, and I guess there's nothing probably the headline out of what you've just said is probably is that, like, if you're losing contracts, you're losing customers, you're losing business, that's a massive impact, isn't it?
Yeah.
Which might not be immediately factored into these sorts of calculations. Yeah, if we talk about the sort of future technology trends, so 89% of our respondents believe AI will significantly impact obsolescence management. What AI applications are you seeing emerge in this space?
Yeah, AI is definitely a hot topic at the minute, and I think when it comes to this, things like predictive analytics for life cycle monitoring, that really enables manufacturers to foresee potential component failures or shortages before they occur. Similarly, with machine learning algorithms, it can help to optimize inventory management and identify the best time to replace or upgrade parts. There's a lot of AI-driven tools out there that help automate things like the redesign processes, which can reduce time and cost when components become obsolete. Additionally, AI can also assist in creating digital twins of systems, which I think we might come onto in a moment. But this enables manufacturers essentially to simulate and analyze obsolescence risks in real time, and it further streamlines the decision making and it improves system longevity.
Okay, but outside of AI, what emerging technologies do you think will transform how manufacturers handle obsolescence?
I think blockchain is another buzzword that I hear a lot, and it's increasingly being explored for tackling the life cycle of components. It offers transparency and security in sourcing and managing parts, and also additive manufacturing or 3D printing is proving a good alternative to sourcing hard to find components. I think it allows for a more flexible, on-demand production of replacement parts. So that's those two areas, I think, outside
So
of
additive manufacturing.
So
Oh,
3D.
can you tell me a bit more about that?
So imagine, you're a manufacturer, and instead of having to source your components that you need, you can just 3D print them in your warehouse.
Right.
I mean,
Okay.
I don't think we're at the stage where that is going to be 100% used, but it's definitely an emerging technology that's very interesting in this space at the minute. If you can get hold of the original design and just essentially print it at home. I use, quote marks.
Yeah.
But, it will save you a lot of trouble in the supply chain.
Yeah. Yeah. I guess we're not going to be there anytime soon with semiconductors, but I can imagine with other parts of a bomb, maybe some of the sort of electromechanical parts, you could imagine that being something that is achievable.
Yeah.
Um, and so on digital twins and simulation technologies, how do you see them affecting component lifecycle management?
So essentially, manufacturers can create virtual models of their systems to simulate different scenarios. So things like component wear or failure, which allows them to predict when a part needs replacing. And this kind of proactive approach helps in planning replacements before issues arise and can reduce downtime and associated costs. And digital twins also enable better design flexibility, so they allow manufacturers to adapt systems to future technological changes, which ensures long-term performance and easier upgrades. So essentially, it enhances the overall system resilience and longevity.
Okay. And what technological investments are you seeing manufacturers prioritize to address obsolescence challenges?
I think they're increasingly prioritizing industrial IoT solutions and cybersecurity enhancements to tackle obsolescence. And I saw this was reflected in your white paper as well. So
Yeah, yeah,
IoT solutions enable remote monitoring, reducing reliance on legacy systems, and offer predictive maintenance that identifies failures before they occur. Again, allowing for more proactive management of components, and additionally, modular connectivity solutions enable easier component replacements, which again improves system flexibility. And cybersecurity plays a crucial role by ensuring secure updates for legacy components, segmenting outdated systems for modern networks, and really identifying security vulnerabilities to aging components. And both of these things together provide more resilience and security in the face of obsolescence.
yeah, yeah. That rings true. I mean, certainly, if you can modularize a design, it means you're not having to replace the entire thing when one part goes out, and it can make the certification process a lot easier. And again, with the things like cybersecurity rules changing, that's also forcing obsolescence of parts that just aren't able to meet future cybersecurity challenges. So in terms of practical recommendations, what advice would you give technical directors facing obsolescence challenges based on what you've observed in the industry?
I think the best approach is to adopt a proactive strategy that focuses on long-term lifecycle management. So invest in predictive maintenance and remote monitoring technologies to identify and address component failures before they occur. Implement modular systems that facilitate easy component replacements, ensuring future scalability. And more importantly, collaborate with specialist partners who can understand your specific needs. These partners can bridge that knowledge gap and provide tailored solutions and help navigate the complexities of obsolescence more effectively.
Okay. The white paper outlines a phased implementation approach. How realistic do you think this is for most manufacturers?
Yeah, I think it's quite realistic, particularly those dealing with complex systems and limited resources. I think by breaking down the process into manageable steps, manufacturers can gradually implement proactive obsolescence strategies without overwhelming their teams. However, success, I think, will depend on their ability to allocate time and budget, as well as their commitment to developing the necessary internal expertise or partnering with external specialists. And I think, like you mentioned earlier, the smaller manufacturers or those with tight budgets may find it challenging, but achievable with the right planning.
Yeah, I think rather than just trying to do it all in one go, breaking it down and looking at the bits that will give you the biggest wins at the sort of least budget and the quickest to implement, and start with that and then work your way down to
Mhm.
the more sort of nice to have areas. What examples have you seen of companies successfully transforming their approach to obsolescence management?
I think one notable example is work done by Siemens in their approach to industrial IoT systems. I know they adopted a proactive lifecycle management strategy for their embedded systems, which focuses on monitoring the components of critical systems to predict obsolescence risks before they become disruptive.
Right.
And essentially, by doing so, they've managed to reduce the cost of redesigns and avoid significant downtime. And I know Rolls-Royce leverage predictive analytics and real-time data from IoT systems, and they
Okay.
also they also use machine learning algorithms to track component life cycle, and it allows them to identify issues well in advance. And I think what these two companies have done is essentially focus on the long-term strategies, not just the short-term fixes, emphasizing the life cycle planning, the flexibility in design, and strategic partnerships with suppliers who can support them through the lifespan of their products.
And they're both in long sector. They're both old companies, aren't they? Big
Yeah.
old companies with probably a very long-term view of the market, and with products and in industries like aerospace and industrial that require that sort of long-term thinking rather than sort of knee-jerk responses. Yeah.
Yeah.
For resource-constrained manufacturers, what first steps would you recommend?
I think that the survey clearly shows that proactive integrated approaches to obsolescence deliver significant benefits. So, we've covered most of these, but lower costs, reduced disruption, faster time to market, enhanced competitive positioning. But implementing these approaches requires more than technical solutions. It demands a strategic shift in perspective that recognizes obsolescence management as a core business capability.
Yeah.
So I think that's the first step, is recognizing obsolescence management as a core business capability rather than just a technical challenge.
Yeah.
And really begin by developing a proactive strategy that perhaps incorporates predictive maintenance and modular designs to extend the lifespan of existing components and systems, and really build that internal capabilities by training staff on obsolescence management best practices.
Okay. So if we talk a bit about the future, how do you see the obsolescence challenge evolving over the next 5 years?
As things like the Internet of Things and AI and other advanced technologies continue to rapidly evolve, I think the rate of obsolescence for embedded systems and components will likely increase. So new innovations will create shorter product life cycles, which will put a lot of pressure on manufacturers to adapt quickly to stay competitive. So, for example, components that are at the cutting edge of technology today
Mm.
may become obsolete faster as newer, more efficient alternatives emerge. There's also the ongoing challenges in global supply chains, coupled with the pressures brought about by certain geopolitical factors. That's going to likely increase obsolescence risks.
Yeah.
Um,
Yeah, in a
manu-
way it did in COVID, didn't it? A lot of um, lines just got shut down completely and were never restarted just because uh, revenue was shifted to the most profitable lines, and the older lines were just seen as, well, it's just not really worth restarting this because the numbers were so low.
Mhm. Yeah, I think manufacturers will ultimately need to focus more on securing long-term component availability and diversify their supply chains to mitigate the impact of any future shortages. And additionally, the rising cost of components and shipping could make redesigns even more expensive. So
Yeah.
that's going to intensify the need for even smarter obsolescence management. And another point which I think I've raised twice already is this talent shortage and this skills gap that we have.
Yeah.
I think there's going to be an increasing need to focus on upskilling the workforce in obsolescence management and life cycle planning, and manufacturers will most likely have to partner with educational institutions or industry specialists to really close these knowledge gaps and ensure that their teams can navigate the growing complexity of these systems.
And what about the impact of changing regulations around sustainability and the right to repair?
Yeah, good question. I think this will likely drive manufacturers to design products with longer life cycles in mind. This may mean using more durable, repairable components and creating systems that are easier to maintain, upgrade, and repair.
Yeah.
So, so as a result, manufacturers will need to carefully consider the availability of spare parts and components, and to ensure that they remain accessible throughout the product's life. And I think sustainability regulations will continue to target the reduction of e-waste, and that's going to incentivize manufacturers to focus on circular economy principles, including recycling and reusing components. And I think as regulators and regulations push for less waste and greater reuse of electronic products, it's going to be natural that manufacturers will design for disassembly and recyclability.
Yeah, and it fits in with what we were talking about earlier about modularization of a design as well. So you're not having to replace an entire design like with a lot of modern cell phones where the whole thing's junk if just one part of it goes faulty. The
Hmm.
ability to actually just replace that one part and keep it going.
Yeah.
What are you most optimistic about regarding UK manufacturing's ability to address these challenges?
The UK manufacturing sector has seen increasing collaboration between businesses, academia, and government, and these industry groups and innovation hubs are working together to address problems like obsolescence and sustainability issues. You have innovations like the Made Smarter program and the High Value Manufacturing Catapult, just to name a few, have provided manufacturers with the support and funding needed to adopt new technologies and enhance productivity and improve resilience to obsolescence risks. And I really think this collaborative approach ensures that manufacturers have access to cutting edge research, development support, practical solutions to address these challenges that they face. And these partnerships between academia and industry will really be crucial in driving innovation in component lifecycle management and system longevity.
Yeah, and I think what we've seen with all the issues with supply chains going on at the moment, that the importance of the UK being able to manage itself and supply itself and be resilient. So that's sort of good news, really.
Mm-hmm.
What resources would you recommend for manufacturers looking to improve their approach to obsolescence?
Well, of course, your future-proofing manufacturing report is a good first start. I think.
Yeah.
I haven't been paid to say that, I promise.
No. Thanks for the plug.
No, I mean, I think your report provides a deep dive into the challenges and best practices for managing obsolescence, particularly in the context of the industrial IoT. And it offers insights on life cycle management and cost-saving strategies and the role of AI as well in obsolescence planning. The IEEE also offers various certifications and development programs related to life cycle management, obsolescence management, IoT integration. And things like attending webinars and conferences is also an effective way to stay on top of current news. So events like Embedded World or Hardware Pioneers Max, they often feature sessions and workshops focused on life cycle planning and obsolescence risk. So it's always worth checking those out.
Constantly reading Electronic Specifier as well to make sure, see what's happening in the industry.
Thank you for the plug.
And that brings us to the end of today's episode. I'd like to thank Paige West from Electronic Specifier for sharing such valuable insights about managing obsolescence in manufacturing. Head over to Electronic Specifier. It's a UK leader in electronic industry news, and there you can hear more from Paige and her team. You can also download our full white paper on future-proofing manufacturing on our website. That's ByteSnap.com. And the full link to that will be in the episode notes. And of course, if you're one of those manufacturers that is suffering obsolescence issues, let us know. ByteSnap's been helping companies worldwide in this area for nearly 20 years. So reach out to our team for more details about how we can help. Finally, big thanks for joining me today. Be sure to like, share the episode and leave us a review. For now, I'm Dunstan Power, and you've been tuned into the Embedded Tech Podcast.